do we need probability and statistics? Why do we need it?
To predict the outcome.
Yes, but why do we need it? Why do we need to predict the outcome?
Lots of big decisions.
Well, because we are living in a world of variabilities. There are lots of uncertainty inside the world, and this is the reality. That's why we need to know the probability, right? So we can say that we need probability and statistics because of variability and uncertainty. And you have noticed that usually the course is all called probability and statistics. Whenever we talk about probability, we also talk about the statistics. But do you know what is the relation between the probability and the statistics? Why they are very tied to each other? Do you remember these two terms? Population and sample. Population means all possible outcomes, everything. Let's say if we want to have picking up one human from Earth, what is the population? 7 billion. So every single human is a population. But we know that population is big. Sometimes it's not accessible. Sometimes we are talking about a continuous variable, which means that we have infinitely many. So we cannot handle it. So what we do, we randomly pick up some and we do an analysis on that one, right? So let's assume that we say we want to pick up one person from planet Earth who is right now living in Estonia. So we have 7 billion people, and we have to do if we want to do the real analysis, we have to use all those 7 billions. But we know that this is not feasible. So what we do, from the planet Earth, we let's say randomly pick up 10,000. And then from that 10,000, we pick up one and we see that what is the probability of picking up someone who is living in Estonia, right? So because population is big, we are handling a small sample of this population, which is significantly less number, but still it's big enough in order to give us some good understanding about how the population behaves. Now, from population to sample science, which helps us to do it, is called probability. Probability tells us how good the sample is, how we have to pick the sample, and how we can get the, I don't know, whatever we want to see. Now, when we get the sample, and from that sample we find out that, okay, let's say 1 person or 2 persons are the people who are living in Estonia, then we will come back and we say that if you pick up someone from the planet Earth with high probability, let's say with 2% probability, the person is living in Estonia. So what happens is that from sample, we start to talk or interpret something for the whole population. And this is called statistics interfere. So that's why that we have the probability and the statistics always tied to each other, because with probability we are from population we go to sample, but then we don't want to talk about the sample. Imagine that you are a quality control engineer and you need to talk about let's say the quality of a product in a company. So what you do, we know that the company works for 100 years and with high probability we work for another 100 years. So we don't have access to whole population because some of the population have been sold out. Some of them have not been produced. So what we do, we from the production line, we pick up some sample and we do all our tests, so we calculate some probabilities. And then you need to write a report, and in your report you say that, let's say, 1% of the product are faulty. So with that 1%, then you will come back by using some statistical analysis to say that, okay, what is the average or what is the standard deviation of, let's say, faulty elements and so on, and then you come to one single conclusion that, oh, the product line is a bad line or is a good line. Now, let's talk a little bit about a few statistical terms which we need them a lot, especially in probability. What is the most famous statistical parameters and terms that we know? Average or mean. Good. So let's define it. Suppose that the observations x1, the observation in the sample, x1 to xn, the sample mean denoted by x bar. In some books we know that it's denoted by mu x. Later in this course we will have a better notation which is called AX. Okay? And it's called expected value. We will talk about it when the time comes. So the sample mean is add all the numbers divided by the total number that we have. Like I want to find the average of the grade in the class, I will add all the grades and I divide it by total number of the students that we have in the classroom. So what is the second important terms and parameter that we know? Abdulaziz? Mode, median, yes, what else? They are not as important as that.
Maybe variance.
Variance, the sample variance. The sample variance denoted by S squared is given by if n is greater than, or let's say if n is big, in our course if n is greater than 25, we can estimate S by this. The sample standard deviation is the positive square root of variance n minus 1 in the denominator shows the degree of freedom associated to this sample variance. And if n is equal to 1, in other words, if we have only one sample, we do not calculate the variance. These are the things that you, with high probability, you know from high school. An alternative formula for calculating sample variance is this one. The proof is quite straightforward. You might know it. If you don't, you can check the proofs in order to see how we can get to that point. Now, these are a few things that you need to know, and let's start to talk about probability and remind and revise a few definitions that we have. The first definition is outcomes. What are outcomes?
Results.
All the possible results, all the possible events that in a probability, in a scenario can happen is considered to be an outcome. Outcomes are possible results of a hypothetical experiment. The most classic, famous examples are outcome of tossing a coin is head or tail, or outcomes of rolling a dice is are what are they? 1 to 6. Outcomes of an outline of a production line in a company. Faulty, not faulty, right? I mean, depends on the scenario, you can define different type of outcomes. But it is very important to find out what are the outcomes, because the outcomes are indicating how we can calculate the probability. said, these are things that you're supposed to know, so I'm just reminding them. I know that it's very boring, but please bear with that. Any recording of a specific outcome, whether it is categorized or numerical. Categorized like faulty, not faulty. Numerical is like number 1 to 6 is called an observation. Another definition is we define S to be a sample space, and it is the set of all possible outcomes in an experiment. So the sample space for tossing a coin is head or tail. Now, we can have one example but different way of representing the sample space. For instance, it's an example. 2 ways of representing a sample space for rolling a dice is, well, definitely one of them is the typical number 1 to 6. Another one is to be even or to be odd. We can have many other forms, like numbers which are, let's say, divisible by 3, numbers which are not divisible by 3. In other words, you can convert it into the binary form, even and odd. Divisible by 5, not divisible by 5. Divisible by 11, not divisible by 11. Be a prime number, not being a prime number. So you can have it in the binary form, or you can have it in this form. How do we know that which one do we have to take? We have to look at the scenario. We have to look at the problem, and accordingly we have to decide which one is what we want to handle. So another typical example which I want you to answer is the sample space of tossing 2 coins is, what is it? It can be number of heads, yes, but what is the typical, the first one that you have seen in high school?
HH?
Yeah, HH, tail, both of them heads, one head, one tail, the first one tail, the second one head, and then both tails. But you are very right, it can be like it can be something like this. S is the number of heads. Can you then tell me that what is it? 2, 1, 0. Right? You can have the similar thing for the number of tails. But the most classical one which you have seen in high school is this, right? Now, this is actually a sample space of tossing 2 coins, and which they are distinctive. In other words, we know what is coin 1, we know what is coin 2. Or, if we don't know it, we toss them after each other. If we have 2 similar coins, and then we toss them together, then do you know what happens? We have 2 similar coins. We have, let's say, 2 50 cents, which have been produced of the same year, same country, and we put them on top of each other, and we toss them, and we look at them. Can you tell me that what is the space? Yes, exactly. In that case, then we will have HH, we will have H, head, tail, head, tail, and then tail, tail. In other words, tail, head, or head, tail will be the same, because we don't know which one is which. But this one, there is a hidden part which we never mentioned it in the lower levels, in the undergraduate and so on, and it is that they are distinctive, or if they are not, we will do them right after each other. So we can have head, tail, and we can have tail, head. But of course, again, it has to be described in the scenario. Now, in this course, we have to be very, define the whole thing in a very, very much of detail. Sometimes, okay, I mean, coin or 2 coins, the number of the outcomes are quite limited. You could write it very easy. But sometimes you have lots of outcomes. So how can we describe it? The sample space of number of students attending any given lecture of probability class is, now assume that 25 students have registered. So what is then sample space in here? Yeah, exactly. It's any number from 0 to 25. So we have to write 0, 1, 2, 3 to 25. Or we write S is x, which x is greater or equal than 0 and less than or equal than 25. Right? And let's have another example in the same part because we want to compare them. The sample space of the lifetime of an is, what about that? We have an electronic component, let's say a lamp, and we want to see what is the sample space of the lifetime of this lamp, or this whatever electronic component you want to think of. It can be any number, but it cannot be some numbers. We have to be more specific, okay? Very good. 0 is acceptable. We can produce it and it can be faulty ones. So lifetime is 0. What else? It's greater than equal than 0. In other words, it cannot be negative. It can be any number which is positive. So we can say S is T, where T is greater or equal than 0. It cannot be negative, but it can be any positive, non-negative number. Now, what is the difference between this example in blue and this example in black? Sorry? Yes, one is discrete, one is continuous. Here, x cannot have any value between 0 to 155. It can have a complete number, it can have an integer as a number. But here, t can have any number. It can be 0.001, it can be 0.0001. So it can be any number, right? So that's a very good starting point to know that now, a bit later, when we are talking, let's say, about random variables, when we are talking about lots of formulas, you have to be ready to see two types of formulas. One for discrete events, one for continuous events. And we will mainly focus on the discrete events because this is a course which is developed for these computer scientists and computer engineers. And we know that the computers are digital, right? Because they are digital, so all the terms are discrete. And even the scenarios in continuous form we approximated by discrete. But we will see all the old formulations, both for discrete and continuous. Now, we have enough knowledge in order to start to define probability and do a few examples on probability. To every point in the sample space, we assign a real number between 0 and 1 called its probability. So as you knew, probability is a number between 0 and 1, and every outcome, every member of the sample space has one value like that. Then sum of all probabilities of all points in the sample space is what? 1. As an example, for rolling a dice, we can write probability 1 plus the probability of 2 plus the probability of 3 plus the probability of 4 plus the probability of 5 plus the probability of 6 is equal to 1. And you understand that P represents the probability. And we all know what is the probability of having 1? 1 over 6 because they are all equal probable. So it's 1 over 6 plus 1 over 6 plus 1 over 6, which is 1. So let's do a small example. These are all revisions or very simple things. That's why I'll go very quickly. But if you have any question at any point, please stop me and ask, even if it is very simple questions. Yes.
So for the probability definition, you're saying for every point in the sample space. So it seems like it's a definition for discrete.
Yes, exactly.
So how do we define it for the continuous case?
For a continuous case, we will talk about the probability of 1 point is 0. So what we talk about up to some point or a range. Otherwise, for one single point in the continuous term, the probability is 0. Now, example. A rigid dice is known to have probability 1 over 2 for the outcome 6 and all other outcomes are known to be equally likely. What is the probability for outcome 2? Again, a very simple question. Yes, do you want to solve it? Thank you. Come on.
It's pretty simple actually.
Yeah.
Probability for 6 is half. We know probability for rest plus probability of 6 should be 1. So probability of rest should be half, and we know and this probability of 1, 2, 3. So since they all are equal, so we can say let's say probability of 2 5 times will be equal to 1 by 2. So probability of 2 will be equal to 1 by 10.
Yeah. Very good. Thank you. Any question regarding that? Suman?
No.
I like to call people so you can compare the handwriting. Well, this is absolutely correct, and I think it's very clear. Now, let's have another definition. So we have talked about an outcome, sample space, Now, we want to talk about something which is some portion of this sample space. For example, what is, we want to talk about finding out the probability of the number of the students attending this class is between, let's say, 3 to 10. So we know that the number is from 0 to 25, but we want to focus on 3 to 10. Or we want to focus on the outcome only 2, although we know that the outcomes are from 1 to 2. So what we want to define is the definition of an event. An event is a subset of the sample space in other words, it is a set of outcomes, but not necessarily all of them. As an example, we can go to roll a die, and we know that the S is from 1 to 6. Let's say event A is outcome is even numbers. Then A is 2, 4, 6. Or event B is outcome is prime numbers. Then B is equal to, what are these? Against?
1, 2, 3, 4.
Against? What are the prime numbers? Do you know the prime numbers? Numbers which are only divisible by themselves or 1. 1 is a very special number. It is not a prime number. So we have 3, we have 5. We have only one even number which is prime, and it is 2. So it's 2, 3, 5. Now, this definition of an event is valid for discrete and continuous. Remember, this definition of probability in general is valid also for continuous, in the sense that the probability is always between 0 and 1. The addition of all the probability of whole the subspace, whole sample space is equal to 1. Or here, the event should not necessarily be a discrete value. It can be a range. For instance, a subset can be, for this example, the subset of the event can be the life of an electronic component is between 10 hours and 20 hours, right? So you can define it, and still the definition is valid. Now, the question is defining the probability of an event. So we are not talking about the probability of one single outcome. We are talking about the probability of an event, which means the sets of these outcomes, or a range of these outcomes that we have. So let's define it. The probability of an event is the sum of the probabilities of all outcomes included in that event. Now, because we are talking about the sum, it's obvious that we are talking about discrete events and outcomes. We will see maybe in a week or two that we can't have the same definition for continuous term. Then we are talking about integral. Right? We are talking about the integral. Now, this sentence that I have written can be also written in another form, and it can be the probability of an event is the sum of weights of outcomes. Because what is a probability value? Probability value is a value between 0 and 1. And if the value is big, it means that that outcome will happen with higher probability. Like here, the probability of 6 is 0.5, whereas the probability of other ones are 0.1. In other words, the weight of 6 is more. So probability also can be referred as the weight of an outcome. Why I am telling you this? Because maybe you are working in pattern recognition and you need to assign weight to each of your features in order, I don't know, maybe train your neural network or do something else. So these probability values are one of the strong things that you can have in your hand in order to have the initial weights for them. Okay? Keep that one in your mind as it can be very useful. So, as an example, which is the continuation of previous example, which we had on the other end of the board, probability of event A is having the probability of number, what was it? Even numbers, right? Probability of 2, probability of 3, plus, probability of 4, plus probability of 6, which is 1 over 6 plus 1 over 6 plus 1 over 6, which is 1 over 2. What is the probability of having an even number in the for the rigid dice of 2 examples ago. Was it 2? Yeah, 2 examples ago. If you look at the one before the last portion of the board, we have this rigid dice. Now we want to see what is the probability of having even number right now.
So a rigid dice could be a property of the rigid.
No. Rigid dice means that the dice which is all the probabilities are not equal. I have built it in a way that one of the sides is heavier, so we will is lighter, so it will land on other side, so I can see that number. So it means that it's not equal probable all the sides. But which side is more probable to happen? I have to tell you, and I'm telling you that the side which has number 6 has the probability of 1 over 2, and we have just proven that the other side has the probability of 1 over 10. Now the question is, what is the probability of having an even number? Yeah, Suman?
Yeah, 7 by 10.
Do you want to do it on the board? Very good. Now, another definition that you might remember from, I don't know, undergraduate or high school was the definition for complement of an event. What is a complement? What is the word of complement? Means the other things, right? So we said, what is an event? The event is a subset of the sample space. So it means we are leaving out some of the samples, some of the outcomes in the sample space. So those ones which are left out are the complement of the ones which we have taken. And the complement has this property that if I put the complement of something by that thing, I will get the whole thing. In other words, if I am picking up the even numbers from rolling a dice, what is left is odd numbers. And if I put these two together, I will get the whole sample space. So complement of an event A is all outcomes in the sample space that are not in A. Complement of A is denoted by A prime, but we have two other notations. In some books it's A bar, and in some others it's A superscript C. But what is important for us to remember and to know is this. A union A prime will give us the whole sample space, and the common element between A and A prime? No, it's empty. We don't have anything in common. Probability of the complement of A is 1 minus the probability of A. In other words, the probability of A plus the probability of complement of A is always 1, which is the probability of S. And note, the probability of null is equal to 0. Again, a few more definitions. A intersected by B denotes the intersection of two events A and B. In other words, A intersected by B means outcomes in both A and B. So, like here, intersection of event A and event B in this example is number 2. Because 2 is also in A, it's an even number, 2 is also in B, it's also a prime number. The intersection between having an even number and odd number, this is 0 now. No, this is empty. Let's not use 0 because 0 can be an odd number. It's empty. We don't have any intersection. As an example, A is even number in rolling a dice, and B is a prime number in rolling a dice. So A intersected by B is number 2. C is odd numbers in rolling a dice. So A intersected by C is empty. So sometimes we see that the intersection is empty, but this intersection empty has a special, it introduces a special property, which we are talking about it now. A and B, I don't write the word events, but from now on we understand A, B, C, these, they are events. A and B are mutually exclusive if they have no elements in common. In other words, A intersected by B is empty. So it means that A and C are mutually exclusive. Okay? We have talked about the intersection. Let's talk about the union. A union B denotes the union of two events, A and B, and A union B, in other words, it means elements, outcomes in A or B or both of them. As an example, for rolling a dice, we can define A to be 2, 3, 5, B to be 3, and C to be 1 in 6. Now, for this example, let's answer these questions. What is the probability of A? What is the probability of B? What is the probability of C? What is A union C? What is the probability of A union C? What is A union B? What is the probability of A union B? Okay, 1 minute, think about it and try to answer it. So one of our Erasmus students will come and solve it as well. You can pick a color. Yeah, we may say it so we can hear it.
So probability of A is 1/2
Okay.
because it's all 3 events and
Yes.
6 possible.
Yeah.
The probability of B would be the only one event when it's 3 and 6.
Yeah. 1/6.
1 over 6, so the probability of C would be 1 in 6, so 2 possibilities, so 2, 6, so it's 1/3.
Yeah.
And A union C would be all possibilities, like in C
Put it in
1,
brackets. Yeah.
2, then there's 3, 5, and 6.
Very good.
Possibility of all those outcomes are 5 and over 6.
Yeah.
Union of A and B would be, well, 3 in both of them, so it doesn't matter, so it's 2, 3, and 5. Still like this, and
Yeah.
there are big possibilities over 6, and it's 1/2 too.
Yeah, very good. Thank you very much. And as we noticed, probability of A plus probability of B, which is 1/2 plus 1/6, which is 4/6 or 2/3, is not equal to the probability of A union B. Whereas in here, it is equal to probability of A plus probability of C, which was 1/2 plus 1/3, and this is 5/6. But let's look at the Venn diagram, because we want to write a very important formula, which I'm sure you know that one. A is 2, 3, 5. 2, 3, B is this, and C is 1 and 6. One thing that we can see from here is this conclusion, that A and C are mutually what? Exclusive. Mutually exclusive, as they have nothing in common. Whereas A intersected by B is element 3. Now, it seems that now we have to relate this union with having some elements in common or not, which is this very important definition. For any two events, A and B, we have probability of A union B is equal to probability of A plus probability of B minus probability of A intersected by B. Now, when we have the probability of A plus probability of B, it counts the common elements twice. So if the element is in A and the element is also in B, it will be counted twice. That's why that we have to subtract it. Now, this basically means is that for mutually, where is it? Okay, mutually inclusive, for mutually inclusive events, probability of A union B is equal to probability of A plus probability of B minus probability of A intersected by B, which we know that what is it?
Common element.
This is common. What is the common element of mutually exclusive? It's empty. And what is the probability of empty? 0. So this one is 0. So for mutually exclusive, it's probability of A plus probability of B. So when they are mutually exclusive, we can see that we can just simply add the elements. But when they are not mutually exclusive, so what happens is that when we only add probability of A plus probability of B, it will not be equal to probability of A union B, because we have element 3 which has been counted twice. So if I subtract 1 over 6 from this one, then I will get, what do I get? I will get 4 over 6, 3 over 6, 1 over 2. Right? Do you have any question? Okay, if you have no question, this is the end of the lecture for today. You can stop the video.